Lesson 10.2 is all about logarithms and logarithmic functions. Those are going to be very similar to our exponential functions. Now, quick example of how logarithms are used. Decibels, sounds. They talk about the sound level or sound waves being 10 to the power of something. So a pin drop is 10 to the power of 0. So 0 decibels. 10 to the power of 2 is the sound waves of a whisper at 4 feet. 10 to the power of 6 is a normal conversation if you're just talking with somebody. So the decibels would be 0, 2, or 20 is actually the power of 2 there. 60, 80, that's just different powers of 10 as it goes up. So a logarithm, just another way to write an equation that's essentially an exponential. So if we have x equals b to the power of a on this side, this is our exponential form, we can rewrite it. And the exact same numbers are going to make log base b of x equals a. And that's how you would say that. You say log base b of x equals a. So one way that I always like to think of it as, your b is your base. I'm going to write that over here. B equals base. Your a is your exponent. And your x, I don't know if there's an official term for this, so I'm just going to call it answer. So your base to your exponent is your answer. That's how logs are written. So let's give a couple examples. Check these ones out here. If we have log base 8 of 64 equals 2, how would we rewrite that? Well, that basically is just saying 8 to the power of 2, or 8 squared, equals 64. Not insanely difficult. Log base 16 of 4 equals 1/2. That's just saying that 16 to the 1/2 equals 4. Log base q of 7 equals t. That's just saying that q to the power of t equals 7. Hey, why did Grandma always pinch 7's cheek? He was such a cutie. That's a hilarious joke. You should probably tell somebody that. All right, this next one. If we have log base x plus 2, so it's this whole thing is our base, x plus 2 equals, or log base x plus 2 of a squared plus b squared equals st. Again, in this case, all it's saying is x plus 2 to the power of st equals a squared plus b squared. So a logarithm is just another way to write an exponential expression or exponential equation that we have. So if we have them in exponential form, how can we write them in a logarithmic form? So 27 is our base to the power of 1/3 equals 3. So we'd say log base 27 gives an answer of 3, so it's 1/3. So the way that I write, or the way that I pronounce it, I would say log base 27 gives an answer of 3 when it's to the power of 1/3. So log base 10 gives an answer of 100 when it's to the power of 2. 10 to the 2 equals 100. Log base x gives an answer of 12 when it's to the power of a. Ooh, this one might get a little hairy over here. Log base a plus b gives an answer of 84x plus y when it's to the power of 7x. So those ones are all written and spoken. So evaluate some logarithms. These are basically just asking us to just say what it is that answer is going to be, or what power of our base gives us our answer. So what power of 10 is 1,000? Well, we'd have to do 10 to the 3rd power equals 1,000. So we'd say that this equals 3. 8 is 10 to the 3rd power, so this one also equals 3. in this case, log base 9 of 3, just saying 9 to what power is 3? Well, it's going to be 1/2. Remember, 1/2 is kind of like doing the square root of it. So this one is going to be 1/2. Log base 8 of -5. In this case, there is no answer, because think about it. 8 to what power is -5? There's no way that we can take 8, this positive number, to any power and get a negative value. If it was to a negative x, remember, that would just make this a fraction over here. It'd still be positive, but it'd be a fraction. If it was like a fractional x that we're looking at, that would just be like taking the square root or the cube root or some other root, which again would still keep this positive. So the fact that this is negative means there's going to be no answer here. And log base 8 of 1 means 8 to the power of what equals 1? Well, that's 0. Anything to the 0th power equals 1. So this one over here equals 0. A couple more to look at here. If we want the inverse property of logarithms, of exponents and logarithms. So we want to evaluate each expression. Well, what this thing is saying here, log base 6 of 6 to the 8. So if we have log base 6 of 6 to the 8, what it's saying is what power over here of 6 gives us 6 to the 8? Well, because we have 6 and 6, we can just cross those out. So we're left with 8. 8. So if we have 6 to the 8th power, that equals 6 to the 8th power. So in this case, our answer is 8. How about this one? What this is saying is 3 to some power. We don't know exactly what that power is, but let's look at just this part here. Log base 3 of 4x minus 1. What this piece is saying, 3 to something gives us 4x minus 1. So we can just call this whole thing y. Well, if this whole thing equals y, and over here it looks like we're doing 3 to the y, we know that from here to here, what we're getting is equals 4x minus 1. So in the end, our answer is just 4x minus 1. 3 to the power of log base 3 of 4x minus 1. So basically what we're getting at here is if you have, in this first case over here, the same base and answer to a power, those all cancel and you're just left with your answer. Same thing here. If you start with a base and put it to the power of a log, that's the same. Those all cancel, and that's your answer. So if we need to solve a logarithmic equation, so we have essentially log base 8 of n equals 4/3. Let's rewrite that really quick. We'd say that it's 8 to the 4/3 power equals n. So we need to solve for n. Well, 8 to the 4/3 power is going to be 16. 16 equals n. You can find that on your calculator. You'll just find it on your calculator. Same thing here. We'll rewrite this in exponential form, 27 to the 2/3 equals n. Again, you can find that on your calculator. No, I will explain how to do it in this case. This base 3 basically means we can take 1/3 power of 27. 27 to the 1/3, remember cubic root, that's going to be 3. So I'm just showing you where we're getting this from. But we still have this 2 on top. So now I have to take the 3 that we got and square it. And so in the end, 9 is our n value. N equals 9. So if we want to go back and explain this one, cubic root of 8 is 2. 8 to the 1/3 equals 2. 2 to the 4, that's where we got that 16 from. So do it on your calculator, or you can figure it out on your own. And here we come to some more solving a logarithmic inequality. So looking at, instead of just expressions and equations, inequalities here. So if b is going to be greater than 1 and x is greater than 0, then our log base b of x is greater than y, then x is greater than by. Similarly, if we have the same setup, but log base b of x is less than y, then 0 is less than x is less than b to the power of y. So basically it just has to be, in this case, that 0 is less than means it just has to be positive. So for example, we have log base 2 of x equals 3. Well, we can just take this, essentially what it's saying, log base 2 to the third power, has to be in sync with our x. We're just taking this log base 2, moving it over to this side, and saying x is greater than 2 to the power of 3. Or, if you want to look at it this way, you can say that we're just taking 2 to the power of both sides. 2 to the power of log base 2x is greater than 2 to the power of 3. And remember from our properties, this and this cancel. So we just have x is greater than 2 to the 3. So that's kind of how it works out there. So if we wanted to try a couple examples here, if we have log base 6 of x is greater than 3, we'll just, like I said, put both sides to the power of 6, or 6 to the power of that. That would cancel out. So we'd have x is greater than 6 to the power of 3, and 6 to the power of 3, then we'd say x is greater than 216. Same thing, log base 3 of x is less than 2, 3 to the power of that, 3 to the power of that, those cancel out. X is less than 3 to the power of 2. 3 to the power of 2, or 3 squared, is just 9. So x is less than 9. Working out pretty slick. So solving equations with logarithms on each side. If b is a positive number other than 1, then log base b of x equals log base b of y, if and only if x equals y. And that kind of makes sense here. X and y are in the same place, so if we have logs of the same base, they should probably be the same number. So x has to equal y in those cases. So, for example, if we have log base 5 of x equals log base 5 of 7, x has to equal 7. Shocker. So, if log base 5 of x is greater than log base 5 of 7, then x is greater than 7. This number right here. Again, shocker. And that actually ends it up for 10.2.